In this session, we will discuss questions related to intermolecular forces. But before discussion, a quick revision what we have completed in this topic. Uh, First, we started with the shapes of the molecule. So, on the basis of number of bond pairs and lone pair, we can predict the geometry. It can be linear, trigonal, planar, tetrahedral, or pyramidal, trigonal pyramidal, or trigonal bipyramidal, bent, or octahedral. So it depends on the number of the bond pair and number of lone pair. And then electronegativity is a tendency of an atom to attract the shared pair of electron. And the covalent bond can be a polar or a non-polar depending on the difference in the electronegativity. And if the electronegativity difference is more than 1.7, then the bond will be ionic. If it is less than or equal to 1.7, the bond will be covalent. And for a covalent bond, it can be polar or non-polar from 0.3 to 1.7. It will be a polar bond, like 0.2 and 0.1 electronegativity difference will be a non-polar. When bonds are polar, sometimes the molecule might be polar, might not be might be non-polar, depending on the geometry of the molecule. As you can see, if we have a symmetrical molecule such as carbon dioxide, so even though the bonds are polar, but overall dipole moment is zero as they cancel out each other, the oxygen atoms. So that's why this will be a non-polar molecule with a polar bond. Whereas chloromethane, it's a symmetrical molecule, not having a symmetry, like one of the bond is different from rest. So this leads to a polar nature of bonds are polar as well as molecule will be polar. A simple experiment how to identify whether a molecule is polar or non-polar. We pass through like a jet of that substance will passes through near the charge rod. If it deflect, it will be a polar. If it is not deflected, it will be non-polar. Then intermolecular force between the covalent molecules can be London force. If the molecules are non-polar, then they will have London force, and it increases with the number of electrons. It can be dipole force. If the molecules are polar, then it will be dipole force, or it can be a hydrogen bond. When hydrogen is forming a bond with most electronegative elements such as fluorine, oxygen, or nitrogen, so as a result, the hydrogen is attracted towards a lone pair of another molecule, leads to hydrogen bond. And the trend how the hydrides of group say 5, 6, or 7, 6, 5, and 4 changes, that trend is very important. You should learn this. Then solubility of a substance for ionic compound, it depends on hydration and lattice energy. If the hydration energy is more, the substance dissolve. If hydrogen energy is more than the lattice, the substance dissolve. And if it is less than the lattice, the substance will not dissolve. And for covalent substances, they should have a same nature or same type of forces. If they have same type of forces, then the substance dissolve. Otherwise, it won't dissolve. So this assignment is related to intermolecular forces. In this session, we'll discuss question. That was a quick revision. For organic compounds, remember, as we increase the number of the carbon atom increase, the dipole forces also increases. Which compounds are arranged in order of decreasing the boiling point? So the boiling point should decrease. So as we know, for hydrocarbon, straight chain hydrocarbon, they will have high boiling point compared to the branched one. So when we check the options, first we have 4 carbon atoms, then 5, then 6. So what happened as the number of the carbon atoms are increasing. So for this one, the boiling point will increase. First we have 1, 2, 3, 4, 5, 6 carbon atoms in a straight chain. 1, 2, 3, 4, 6 in a straight chain. Then there will be one branch and then 2 branches. So what happened as the number of the branches increases, the boiling point will decrease. So this straight chain will have high boiling point. Then when one branch is there and one branch will have high boiling point, then 2 branches. So B is the right answer. What about this one? When you check, there are 3 carbon and OH group is there. Then 1, 2, 3 carbon and 2 OH groups are there and 3 OH. So as the number of the OH groups are increasing, the boiling point will also increase. What happened here? First it is CH3Cl, then CBr, and then CH3I. So when we check the intermolecular forces, if you remember, like the bond between carbon and chlorine, it will be more polar compared to bond between carbon and bromine. But because bromine is having more electrons, it will have a stronger dipole induced dipole force. So that's why it will also increases. Even though iodine also it's having more electrons than bromine, so the boiling point will further increase. So the correct answer is B. Is it clear? So the number of the branches and number of the if the number of the branches increases, the boiling point will decrease. Another question, how do the boiling temperature of ethanol and chloroethane compare, and what is the reason for the difference? So when we compare ethanol, eth means two carbon and OH. So because of the carbon chain, it will have dipole induced dipole force. Because of OH, it will have hydrogen bond. Whereas chloroethane, because of the carbon chain, it will have dipole induced dipole and partial positive and negative. So that will be dipole dipole forces. So which one, as we know, when we compare the intermolecular forces, hydrogen bonds are stronger compared to, like, if same number of electrons are there in the system, hydrogen bonds are stronger than dipole dipole force, and then the dipole dipole force is stronger than dipole induced dipole. But as the number of the electron increases, the dipole induced dipole force will also increase. So which one will be higher? Because hydrogen bond is there in ethanol, so ethanol will have a higher boiling point. And what could be a reason for the difference? Because ethanol molecules can form hydrogen bond. So A is the right answer. So if a molecule can form a hydrogen bond, likely it will have a high boiling point. In question 3, this question is about trend in the periodic table. The boiling temperature of some isoelectronic hydra. When we say isoelectronic, it means they have the same number of electrons. As you can see, carbon is having 6 electrons and hydrogen 4, so total 10 electron. Nitrogen is 7 and hydrogen 3, so 10. Oxygen is 8 and hydrogen 2, 10. And fluorine is 9 and hydrogen is 1, so 10. So total 10 electron, that's why we call them as isoelectronic. Explain the difference in the boiling temperature by considering all the intermolecular forces involved. Detailed description of intermolecular force involved are not required. Like, they don't ask like what is the origin. If you say hydrogen bond, what is the origin? They don't need that, but it is of 6 marks. So how you will write the answer for this? First, the first one, CH4 is having the London dispersion force or dipole induced dipole force. First, we identify the type of the bonding. So in CH4, what kind of force is there? It will have London dispersion force. Even you can say London force or dipole induced dipole force. Whereas NH3, H2O, and HF, they will have hydrogen bond. So first, when you mention the type of the bonding, for methane it is dipole induced dipole, and for water, ammonia and hydrogen fluoride, it is hydrogen bond. So you will score 2 marks. Then we will compare the strength, because as we can see from the result that CH4 is having a low boiling point. So it means that dipole induced dipole force or London forces are weaker than hydrogen bonds. So when we mention this will score 3 marks. Then when we compare, because the reason in the question, if you read the question, they mention they all are isoelectronic. So when isoelectronic means they have the same number of electron. And as I mentioned yesterday, that this dipole induced dipole force is always there. Strength vary depending on the number of electron. So as they mentioned, they are isoelectronic. So you will mention that all the molecules have same strength of London forces. The first point, what when we mention methane is having dipole induced dipole force, what it is referring to a major force. There is dipole, like same thing for ammonia, water, and hydrogen fluoride. There is dipole induced dipole force, but in the beginning we do not mention, because we were talking about the major force. So major force is ammonia, water, and hydrogen fluoride is hydrogen bonding, whereas major force in methane is dipole induced dipole force. And then London forces are weaker compared to hydrogen bond. All the molecules have the same strength of London forces because they have same number of electrons. So as the number of electrons are same, they will have the same. Then when we compare, the fluorine is having a greater electronegativity than nitrogen and oxygen. So its hydrogen fluoride bond will be most electronegative, HF bond. And then why the water is having the highest boiling point here in this, because the water molecule has more hydrogen bond. So water is having the highest boiling point because the water forms more hydrogen bond than compared to HF and NH3. Is it clear discussion? That we compare, like methane, it's having only dipole induced dipole, the others having dipole induced dipole and hydrogen. But when we compare the strength of dipole induced dipole force, that is same for all the molecules as they have same number of electrons. And in case of water, water is having the highest boiling point in all three, even though the bond of hydrogen and fluoride is more polar, so it should be stronger, or it should have a high boiling point, but it is not. What is the reason for that? Because the water molecule is able to form two hydrogen bonds, whereas in hydrogen fluoride there is only one hydrogen bond, same as for ammonia. Another question, which of the following statement about water is not due to hydrogen bond? Like due to hydrogen bond, which of the statement is not there? So when we check, water has less open structure than ice. That is true, because if you compare the density of the ice is smaller as compared to density of the water. That's why the ice will float on the surface. So water has less open structure. Open structure means like less space between the molecule. And what is the reason for that? The reason is hydrogen bond, because in water molecule the particles, as they're moving around each other, so they can have more chances to attract. So this property is due to hydrogen bond. The ice cube float in a glass of ice water, that is also due to hydrogen bond, because in a liquid state the hydrogen bonds are much stronger in case of water. That's why it will have a high density. So the ice is having a low density, that's why it float. When water freezes, its volume increases. That's also true. The molecule arrange themselves in a regular pattern. So when they arrange, they slightly move away from each other, so the volume increases. Water is a good solvent for ionic compound. So that's why it is a good solvent for ionic compound, because that is due to polar bonds. Water is having a polar bonds, like the bond between hydrogen and oxygen is a polar one. That's why it is a good solvent to dissolve the ionic compound. So this property is due to polar bond, nature polar bond, not due to hydrogen bonding. That's why D is the right answer. Is it clear discussion? Then question 5, the skeletal formula of three isomers are shown. Which series shows a correct increasing the boiling point? So as we know, as the number of the branches increases, the boiling point decreases. So this is, first we check the number of the carbon, 1, 2, 3, 4, 5, 6 carbon. All have 6 carbon atoms. 1, 2, 3, 4, 5, 6. Yeah. So all have 6 carbon atoms. This is having two branches. So this will have the lowest. This is having one branch. This is having no branch, so large surface area, this will be highest. So higher, the increasing boiling point, so Y will have the highest boiling point and X will have the lowest. That's why D is the right answer. So, and sometimes they ask a reason for that. So what will be the reason? You will mention as a number of the branches increase, the surface area in contact for a molecule decreases. That's why the boiling point decrease. Question 6. Explain with reference to intermolecular forces why the boiling temperature of alkane increases as the number of carbon atom increase. A detailed description of intermolecular force is not required. What they mean here, that detailed description not required, means you don't have to mention the origin, what is the origin of this, how these forces arise. You just have to explain the idea. So what happened? First, these hydrocarbons, they have London dispersion forces or London forces or dipole-induced dipole forces. As the number of the carbon increase, the number of electron increases. So there will be more force between the particle. So alkanes have dipole-induced dipole forces. That is one thing. Then the number of the carbon, the increase, as the number of carbon increase, so the number of electrons will also increase. And as the number of electrons will increase, um, this force between the molecules will be stronger, need more energy to separate the particles, leads to increase in boiling temperature. So this is what happened in case of alkanes. Next, question 7. Which of these isomer of formula C8 and H18 has the lowest boiling point? So what you have to do, the best way, you try to draw the structure. If you draw the structure, you can easily identify that. So when we check, like if I draw the structure of A, it will be basically, when this is written, this is a branch and this is also a branch here. So two branches. When we check, this is one branch, When we check this CH3, so and bracket 2 is there, so two branches here and three. So this is having three branches. This was having two branches. This is having one branch. And this is having zero branch. So we know the boiling point and the number of the branches are opposite. As the number of the branches increase, the boiling point decrease. So lowest boiling point should have the highest number of branches. That's why C is the right answer. Is it clear, this question? 7. Then which of these pure compounds have hydrogen bond in liquid state? Hydrogen bond can only exist, remember, whenever in a molecule hydrogen is bonded with fluorine, hydrogen is directly bonded with nitrogen, or hydrogen is bonded with oxygen. Only these three scenarios hydrogen bonding can exist, otherwise it does not exist. So here we don't find any bond of HF or HN or HO. Here nitrogen is, if you draw the structure, basically it's like nitrogen is bonded with carbon, not hydrogen, because to form a hydrogen bond nitrogen should be connected with hydrogen directly, but here it's indirect, like nitrogen is there connected with carbon, so that is why it is wrong. Hydrogen fluoride, that's correct, and hydrogen sulfide, again that is wrong, because hydrogen is not forming a bond with, like hydrogen bond is not an intermolecular force. For all the cases, only three cases are there. A molecule in which there is a bond between hydrogen and fluorine, or hydrogen and oxygen, or nitrogen, that will always leads to hydrogen bonding. The viscosities of four liquids, viscosity means property of a fluid to resist the flow. Like viscosity of four organic liquid compounds by placing the liquid in a separate identical tube and each with an air bubble at the top. The tubes are inverted, so when we invert the tube, the bubble will rise. The time it takes for bubbles to travel up. Which compound does the air bubble take the longest time? So the compound which is having the highest viscosity, the air bubble will take the longest time. So we have to check the intermolecular force to identify this. So when we check the type of intermolecular force, this will have two things. Because of carbon chain, it will have London force. I'm writing LF, and because of hydrogen bonded with oxygen, so hydrogen bond. The second compound will have London forces as well as hydrogen bond. But how many hydrogen bonds? Like two sides it can form. The third one, London forces will be there, but one, two, three sides it can form hydrogen bond, and each oxygen can further form two bonds. So for this molecule, carbon is partial positive and oxygen is partial negative. This will have London force and dipole force. So which one is the strongest for the hydrogen bond is strong? And there are three hydrogen bond for this. That's why C is the right option. Is it clear, this question, that how we work out? Because the one which is having the highest viscosity, like greater tendency to resist the flow or stronger attraction between the molecule, that will not allow the air bubble to move freely. In question 10, this is about the bond angle and predicting the shape of a molecule on the basis of the bond angle. So hydrogen ion bond to a water molecule from H3O. So what will be the structure of H3O? So there will be a dative bonding here, dative bond, and there's one lone pair. So when we predict the geometry, we always predict according to the central we this is oxygen. So with respect to oxygen, on oxygen, how many bond pairs are there? One, two, three bond pair, and so there are three bond pairs, and there is one lone pair. So three bond pair and one lone pair. What will be the structure? It will, because if four bond pairs are there, it will be tetrahedral. But if three bond out of four, three are bond pair and one lone pair, and we know each bond pair, each lone pair decrease the angle by 2.5. So when four bond pairs are there, it will be tetrahedral with a bond angle of 109.5. But now out of four, three of them are bond and one is a lone. So due to each lone pair, the bond angle decreased by 2.5. So 109.5 minus 2.5, that is equals to 107, and 107 is trigonal pyramidal. So you can learn that table as in the beginning of the session we discussed. So you can memorize the table, or you can also like use the idea to predict the bond angle. The structure of DMAA is only slightly soluble in water but dissolve readily in hydrochloric acid to form an aqueous solution. So it dissolves in hydrochloric acid but does not dissolve in water readily. Slightly soluble in water but readily soluble in hydrochloric acid. Then explain the type of the bonding that occur between the nitrogen atom and the hydrogen ion. The hydrogen ion is transferred, so what kind of bonding is there? And when the positive ion is formed, so when they form a positive ion, so the bond between nitrogen and hydrogen is a dative bond here, because hydrogen is attracted towards a lone pair of nitrogen, as the hydrogen does not have any free electron. So we have to state the type of the bonding. So there's a dative bonding, and how it is formed. Nitrogen is having the lone pair, which attract the hydrogen ion. So it is attracting the hydrogen ion. Hydrogen does not have electrons, so this attraction between them, so attraction between hydrogen ion and lone pair leads to dative bond. So it is like NH2 means there is a lone pair here, and this lone pair, because HCl acid are proton donors, so it will donate it proton H plus ion, and this H plus ion is attracted towards the lone pair and leads to formation of a dative bond. Then complete the diagram to show how the ions form in the reaction between DMAA and hydrochloric acid interact with the water molecule. So positive ions, how they will interact? Yesterday, as we discussed the concept of hydration energy, that oxygen is partial negative, so oxygen will be attracted towards the positive ion, and hydrogen is attracted towards the negative ion. You have to show the charge on them. This will be partial positive, not full positive, partial. This will be partial positive hydrogen, oxygen partial negative, partial positive. And same way, oxygen is partial negative, hydrogen partial positive. Another question, question 12. Which of the following molecule contain polar bonds but a non-polar molecule? Bond should be polar, but the molecule should be non-polar. When we check chlorine, because same electronegativity, so the bonds will be non-polar. When we check HCl, bonds will be polar and the molecule will also be polar because net dipole moment does not cancel out. Like there is no other substance, other atom to cancel out, so there will be partial positive on hydrogen, partial negative on chlorine, and the other molecule also partial negative and positive. So the molecule is polar and the bonds is also polar, so this cannot be an answer. Trichloromethane. In trichloromethane, it's asymmetrical molecule. So when the molecule is not having a symmetry, the bond, because if two different atoms are there, bond will be polar. That is correct. The first state. But second, the molecule will not be non-polar. The molecule will also be polar because one of the hydro, like there one side we have chlorine and three hydrogen, so it is asymmetrical molecule. So molecule if does not have the symmetry, then it will be a polar molecule. So it cannot overall cancel out the effect of partial positive and negative. So we are left with tetrachloromethane because in tetrachloromethane the bonds will be polar as the bonds are formed between the different atoms. But as a result, like if I say this chlorine is attracting by a force of 20 Newton, the other chlorine will also try to attract with the same force. So they're trying to attract with the same force. As a result, what happened? As a result, the overall molecule will be non-polar. So D is the right answer. In question 13, which of the following has a dipole-dipole interaction between its molecule but no hydrogen bond? Hydrogen bond is there. This will have hydrogen bond. This will have hydrogen bond. This will have two things. It will have dipole-induced dipole or London force as well as dipole-dipole force because hydrogen and iodine, they have difference in electronegativity. But in case of CH4, because the molecules are totally non-polar molecule and non-polar molecule will always have dipole-induced dipole force or London dispersion force. So methane or A is the right answer. The methanol will have hydrogen bond and London forces. London forces are always there because when you have electrons, there will be force between the attraction between the electrons and the nucleus of the atoms. So we call that as a London dispersion force. In question 14, which list below shows the compound in order of increasing the boiling point? So boiling point is increasing. When we check, CH4 will have low boiling point, then HCl and HCl will have low boiling point than HF. So it will be because CH4 will have dipole induced dipole force, HCl will have dipole dipole forces, and when we compare as well as dipole induced, but HCl will have a stronger dipole induced dipole forces as well because it is having more electrons. But in HF, the dipole induced dipole force, even though it is weaker, but hydrogen bond is stronger, that's why it leads to a high boiling point. So A is the right answer. Then which of the following has the highest boiling temperature? Pentane, hexane, 3-methyl. So whenever we check the boiling point, we should check the number of first electrons or number of atoms which are having electrons. So all are carbon and hydrogen atom, and then we check the total number of carbon, 1, 2, 3, 4, 5, 6 carbon here, 5 carbon, 6 carbon, and 5. So this will have the highest boiling point because greater number of carbon and no branches. So this will have a large area. Greater number of carbon refers to strong London forces, and it's a unbranched hydrocarbon or a straight chain hydrocarbon. It means it will have a large surface area. Which use your knowledge of intermolecular force predict the compound with the highest boiling point. So even though these three have hydrogen bond, and hydrogen fluoride hydrogen bond is stronger, but what happen as a result, because water can form in water there can be two hydrogen bond with oxygen as compared to hydrogen fluoride or NH3. That's why it will have the highest boiling point. Then use your knowledge of intermolecular force, predict the compound with the highest boiling point. So how we can work out the compound with the highest boiling point? We have to check. So iodobutane, chlorobutane, this is a branch. So branch one cannot have if they have the same number of branch. So either it is iodobutane and chloro. But what happened in chlorobutane? Few electrons are there, so it will have weaker London force. But in iodobutane, because iodine is attached, more electrons, so it will have. When we compare London force, it will be weaker here. Dipole force will be stronger. Partial positive negative. Here, partial positive negative, iodine is less electronegative. So dipole force will be weaker, but the London force is stronger, and it is much stronger. Why? Because there is a greater increase in electron number. So iodobutane will have the higher boiling point than 1-chlorobutane. Then tetrachloromethane is, so whenever two different atoms are there, their bond will be polar. So carbon and chlorine bond will be polar, partial positive and negative. But what will be the difference? The molecule will be non-polar because a symmetrical molecule. So molecule will be non-polar, but the bonds will be polar. Then question 19, the difference in the boiling temperature of methane and ethane is the best explained by different number of. So what is the reason why they don't have hydrogen bond? They will have different number of covalent bond, but that is not the difference. The difference is due to number of electron. As the number of electron changes, the dipole induced dipole force also changes. As the number of electron increase, the dipole induced dipole force will also increase. Then ethanol is soluble in water, dissolve in water. The best explanation for this. So why ethanol or alcohol can dissolve in water? Because ethanol molecule form hydrogen bond with, they have identical types, so they can form a hydrogen bond. That's why ethanol will dissolve in water, or it will be miscible or mixed with water. Question 21, OH bond in water is polar because compared to hydrogen atom, the oxygen atom has. So what is the difference? Because there's a greater difference in the electronegativity, that's why it will be more polar. And which of the following compound has the highest boiling point? So the one which can form, this will have London force. The first example will have London force, major force. The second one will have dipole force. The third one will also have dipole force, because hydrogen is not bonded, because it is C double bonded with O and H. So hydrogen is not bonded directly with oxygen. But the fourth one is hydrogen bonding, which is a strongest. Then strongest intermolecular forces in ammonia are hydrogen bond, that because the nitrogen forming a bond with hydrogen, so the molecules are linked together by a hydrogen bond. So this was exercise related to intermolecular forces. There are many questions, similar questions are there. Any question related to the class today? So I'll end this session and share this with you.